Mars doesn't have a strong global magnetic field like Earth, but that doesn't mean it's unprotected. Thanks to NASA's MAVEN spacecraft, scientists discovered that Mars has powerful electric currents flowing in its upper atmosphere, creating a dynamic electromagnetic shield known as an induced magnetosphere. These invisible currents form when the solar wind, streams of charged particles from the Sun, collide with the Martian atmosphere. Without a strong magnetic core to deflect them, the solar wind wraps around the planet instead, bending magnetic field lines and creating swirling current sheets in space. MAVEN's instruments detect these complex fields, mapping how solar energy shapes Mars' electromagnetic environment and helps strip its atmosphere. When solar storms strike, the electric currents grow stronger, leading to bursts of auroras and faster atmospheric loss. It's like Mars has crafted its own electrical armor, fragile, patchy, but constantly at work. Through MAVEN, we now see how invisible forces can shape the destiny of an entire planet. True or false? Mars has a strong global magnetic field that protects it from solar wind. False. Mars lost its global magnetic field billions of years ago. Today, it relies on electric currents in its upper atmosphere to form a weak, induced magnetosphere. What forms Mars' induced magnetosphere? Electric currents from solar wind. Fill in the blank. Mars has an blank magnetosphere, not a global one. Induced. Fill in the blank. The spacecraft studying Mars' upper atmosphere is called blank. MAVEN. Which spacecraft studies Mars' atmospheric electric currents? MAVEN. If an atmospheric particle takes 2.5 minutes to travel 750 kilometers along a current sheet, how long would it take to travel 1,800 kilometers at the same speed? To find out how long it takes to travel 1,800 kilometers, we first calculate the speed. 750 kilometers in 2.5 minutes gives us 300 kilometers per minute. Then divide 1,800 by 300, and we get 6 minutes, the time it takes to ride the current across Mars' upper skies. True or false? Electric currents on Mars become stronger during solar storms. True. Fill in the blank. Electric currents are created when blank wind hits Mars. Solar winds. Which of the following can increase Mars' atmospheric loss? Solar storms. Fill in the blank. Draping of magnetic field lines around Mars occurs in the blank region. Bow shock. True or false? MAVEN is a spacecraft designed to map Mars' magnetic and electric environment. True. If solar wind particles move at a speed of 500 kilometers per second and interact with Mars' electric currents for 15 seconds, how far do they travel? Multiply the speed of 500 kilometers per second by 15 seconds, and you get 7,500 kilometers. That's the distance these charged particles travel while interacting with Mars' upper atmosphere. Where do current sheets on Mars typically form? Above the upper atmosphere. Fill in the blank. Strong electric fields can cause atmospheric particles to blank. Escape. If a charged particle travels 4,800 kilometers in 8 minutes, what is its average speed? Divide 4,800 kilometers by 8 minutes to get 600 kilometers per minute. That's the particle's average speed as it moves along Mars' atmospheric electric field. How did you do? Tell us in the comments below. And thanks for watching Brainy Kids. We hope you had fun today. Like, subscribe, and hit the bell so you never miss a quiz. See you next time, brainy friends.